Hello students, Sacred Heart High School welcomes you. Let us study Chapter 9, Heat. In the first part of this chapter, we had studied about transfer of heat, modes of heat transfer, that is conduction, convection and radiation. We had also studied about properties of heat, good and bad conductors of heat. In this part, we are going to study about expansion and contraction of substances, and we will also study about the thermos flask. Now, let us study about the first part, that is expansion and contraction of solid substance due to heat. Let us study this with the help of an experiment. Apparatus, a metal ring, a metal ball, a burner, etc. Procedure: take a metal ring and a metal ball of such size that the ball just passes through the ring. Heat the ball and check whether it passes through the ring. Now let the ball cool down and check whether it passes through the ring. Take a metal ball and try to pass it through the ring. You will see that it easily passes through the ring. Then you heat the metal ball and try to pass it through the ring. You will see that the metal ball does not pass through the ring easily. It happens because when the metal ball is heated, the particles of the metal ball starts vibrating and they start expanding, and that is why the ball does not pass through the ring easily. Now you cool the metal ball. Then you try to pass the metal ball through the ring. You will see that the metal ball easily passes through the ring. This tells us that the metals contract on cooling. Metals expand on heating, whereas they contract on cooling. Means the particles which had expanded earlier, they come back to the original shape when heat is removed. So from this we can say that when solid metal ball is heated, it expands, and when the metal ball is cooled, it contracts. Expansion and contraction of liquid due to heat. Apparatus: 500 ml conical flask, 2-holed rubber stopper, glass tube, measuring ruler, thermometer, stand, wire gauze, burner, graph paper. Procedure: fill the conical flask completely with water. Insert the glass tube and the thermometer in the 2 holes of the stopper and fit it to the conical flask. Heat the water and with the help of the ruler record the water level in the glass tube after every 2-degree rise in the temperature. Take about 10 readings. Observe what happens when heating is stopped. Draw a graph to show the change in the water level as the temperature rises. When we start heating the water, the temperature of the water starts rising and the water starts entering the hollow glass tube. Record the water level in the glass tube after every 2-degree rise in the temperature. Here you will see that when a liquid is heated, the distance between its particle increases, means its density decreases and its volume too increases. This is called as expansion of liquids. Whenever a liquid is heated, it expands. It expands means its particles starts moving away from each other and its volume increases. But when the heating is removed, the temperature falls and the liquid contracts. The liquid comes back to its original shape. This is called as contraction of liquid. Expansion and contraction of gases due to heat. Apparatus: glass bottle, balloon, hot water, etc. Procedure: fix a balloon on the mouth of a glass bottle. Hold this bottle in hot water. What happens? The volume of gas increases on heating. The gas which is present in the empty bottle, it expands because of the surrounding hot water. The surrounding hot water allows the air particles or the gas particles to move away from each other and it helps it to expand. That is why the gas which is present in the bottle enters the balloon and the balloon starts inflating. On the other hand, on removing heat, the volume of gas decreases. When you remove the bottle out of the hot water bowl, you will see that the gases come back to its original shape. This is called as contraction of gases. Thermos flask. Thermos flask is a double-walled flask. It consists of two glass tubes which are placed one inside the other with the gap between them sealed. Sealed means closed. The surface of both the tubes are made shiny by a silver coating. The air between the two tubes is removed to create a vacuum. Here, vacuum is created so that heat does not come out by conduction. There is a protective jar of metal or plastic outside the tubes. For the protection of the flask, pieces of sponge or rubber are fixed between the outer jar and the flask. To avoid the breaking of flask or tubes, pieces of sponge or rubber are fixed. Function of the thermos flask. When a hot substance is placed in a thermos flask, the heat going out gets reflected due to the shining surface of the inner tube. Hence, heat is not radiated. Neither conduction nor convection occurs because of the vacuum. As a result, heat is not transferred to the outer cooler region and it is retained inside for a long period of time. Still, a little amount of heat comes out when the lid is opened. Therefore, the hot substance does not remain as hot after 2 or 3 hours. I hope you have understood this part. Thank you.